just want to know if you've got any questions on that or any comments that you want to raise before we start. Guys, I'm gonna maybe ask that you not record. I'll record the session, because if I record the session, I can share that session on the MyTutor platform. So I see someone has started recording. So I don't know who that was. Okay, anyway, then we'll just keep it at that. Guys, do you have any comments or questions that you'd like to raise while we wait for the other students to join? None. Okay. Great. If you're happy, I'm happy. Guys, today we're going to be starting with chapter 2. The chapter is called Bringing Systems into Being. So we're going to start talking about life cycle, what life cycle design means. So first we're going to go chronologically in terms of design, and then we're going to break it up into our company profiles. So we're going to start with life cycle, which is the chronological, meaning timewards development of a product and what to consider and when to consider it. So if you just give me a moment, I'm just going to close my window so that there's no traffic noises coming through. There we go. All right. Guys, today's not going to be a very long lecture, but I've got 2 examples that I want to show you at the end, which I think is going to be good. Okay, guys, please just remember online protocol. Keep yourself muted. If you have a question, raise it. If I don't recognize your hand that was raised, please just unmute and then you can talk. Thanks, guys. All right. So without any further ado, we've quite a few students. So let's get started with our lecture today. Okay, so we're looking at chapter 2. So the chapter is called Bringing Systems into Being. Okay? What we're going to be talking about is life cycle analysis, because a system functions in a life cycle. So there's a few different considerations that we must look after. So when we think of product design, we think of developing and designing and producing a product. So I've got my cell phone in front of me. So what do we think about product or designing a system, bringing a system into being? I think about the cell phone alone. But that isn't the case when we design a system. And I'll show you a little bit more as we carry on through the presentation. I've got a resource that I want to share with you. I'll carry on talking about that on Thursday, which is a book, an additional book that you guys can read in your own time that I think will add value if you go forward and you do become a designer or a systems engineer. But let's start talking about systems. So when we consider human-made systems, and we've spoke about this in chapter 1. They've got these characteristics, right? They've got a functional purpose. And what we must remember is that functional purpose in human-made systems, that functional purpose responds to something. It responds to a need. And it has an operational objective. So this system has a purpose, a functional purpose. We're designing it for a reason. So if we just design a system or a product or whatever, just to design a product, then it isn't proper systems engineering. Systems engineering or human-made systems design comes from a point of view where there's a need for it. We have to solve a problem. Okay, so that's the first thing, functional purpose. Every system, a human-made system, has to have a functional purpose. They are brought into being and operate over a life cycle. So you can see that here we're starting to talk about life cycle. And we're going to expand on that in this presentation. Guys, let's just keep yourself muted. Thank you. So they are brought into being and operate over a life cycle, beginning with a need and ending with a phase out and disposal. So there you're already getting a hint of what is incorporated into systems design. So we start with the need. Where does that come from? If we've got a company, that usually comes from the customer or the client or the environment where we're working in. And it ends with the phase out and disposal of our system. They are composed of a combination of resources. Okay? So we spoke about this. System isn't just one item. It can be an integration of humans, information, software, materials, equipment, facilities, and money. I heard Elon Musk say the other day about his Tesla cars. They're as much hardware as they are software. So what he was referring to is all these self-driving cars that he's been developing. So they do have the hardware facilities. They're a functioning car. They've got electric motors that they drive up and down with. They can charge, you can drive them. So that's the physical side. But then it's also a software component, right? So it's got quite a complex software package that runs these cars, that make decisions and all of that. So a combination of all of these components, especially in these days, or resources, forms our systems. So it's where the humans and the information and the software and the materials and the equipment meet, right? The facilities and money is also an important aspect. Guys, please keep yourself muted. Thanks. All right. Engineering systems are composed of subsystems and related components that interact with each other and produce a system responsible behavior. We know that's already right. So there's systems and then there's subsystems, and those subsystems have components, and all of those things interact with each other. We had a question last week about can there be a component that doesn't interact with the others? And we had a short discussion about that. Remember the drawing that I drew also on PowerPoint? It's in the last lecture recording of how systems and subsystems hierarchically link with each other, right? Engineering systems are part of a hierarchy and are influenced by external factors from larger systems of which they are a part of, right? So we spoke about the flock of birds and the environment where they fly in. We spoke about us producing a car, and we have to compete with other producers, and we have to interact with the environment. For instance, in South Africa, regarding roads and infrastructure, it might influence our strategies in the company. We might see that in South Africa, there's better roads or worse roads, and we might focus on a specific product line, namely SUVs or those type of vehicles instead of cars. So that might also influence our decisions when designing and implementing a system, is how they are influenced by external factors. We all know that there's a war going on up in Europe between Ukraine and Russia, or between Russia and Ukraine. And how does that influence world economy? How does that influence economic influences? For instance, if you've got a company in Russia and you're exporting, you might have some trouble now because of international sanctions, right? So how does your product fit into the environment? Engineered systems are embedded into the natural world and interact with it in a desirable as well as undesirable ways. So that's what we're also speaking about. So not only a car that's running on a road, right? How does it interact with the road, but also in terms of our business and how it interacts with the business environment around it, right? So those are engineered systems. So all of this is a summary of what we spoke about last week and the week before in terms of chapter 1. All right. So I want to move towards life cycle analysis and the product. Right? So if we are engineering systems, remember what I said about the history of systems engineering? It comes from aeronautical engineering, where aeronautical engineers wanted to develop an approach to improve the entire design and interaction in their companies. And that's where systems engineering was born. And after that, obviously, developed into a lot of manufacturing industries and even other analyses. We looked at video where the guy used systems and complex systems analysis to consider world economy. So it has become a very broad application. But in the cases that we're considering as industrial engineers, is all about company design in the manufacturing environment or in the service environment. So that's where we're focusing. So I'm going to move towards system engineering and the product. So the purpose of engineering activities of design and analysis is to determine how physical factors may be altered to create the most utility for the least cost in terms of product cost, product service cost, and social cost. So I'm going to talk about that a little bit using our examples. So I've got two examples at the end where we're going to say, okay, product cost, product service cost, and social cost. So in this competition capitalist environment where we're working in, how do we gain ground and what is our aim? Our aim is to make profit and or to create value. Let's put it that way, to create value. So that's where we're aiming at. So as a system engineers, we want to design engineering activities to determine how physical factors may be altered to create the most utility for the least amount of cost. And that's where the catch comes in there. Most utility for the least amount of cost. What's a good example of that? So if we're looking at automotive manufacturing, you've got a series of a single model of car. So I'm going to use two examples later on, and we'll talk through those examples very specifically. But for instance, if you buy a VW Polo, there's a whole range of different Polos that you can buy, right? So there's a few different engines, and there's a few different luxury options in the interior and so on. But most of those are modular. So for instance, one of those engines can be used in different cars. Yeah? So VW I think is a bad example in that regard because they develop their own engines, but other automobile manufacturers, like you might know, Nissan and Renault have an alliance. So there might be an interchange of engines. So you might find the same engine in a Micra that you might find in a Clio, for instance. There might be small alterations, but being able to create such a modular system that can be used in more than one vehicle, that gives us a lot of utility for the least amount of cost, right? So we live in an environment where customization is the key point. Everything must be customized. I always use the example of when was the last time that you saw a Jeep on the road that isn't a limited edition, right? So most Jeeps are limited. So it's a limited edition. It's a one-time only. You want it like you want it. It's customized, right? And you want to buy it off the shelf. Now, how can we customize every product for every single client and yet still maintain that financial prowess that mass manufacturing gave us? And the key in that is through modularization, right? So in that case, we can get the most utility for the least amount of cost because our development costs and production costs and facility costs or production facility costs are lower, but we reach a huge amount of utility. Okay, so that's just one example. So that's what our purpose is to create the most utility for the least amount of cost. And that cost can be many ways. So it's product cost, yes, service cost as well, and then also social cost. When I was working with water affairs, that was a very big concern. When we built a dam, we in the catchment area of the dam, we usually relocated communities, right? So our rule was they have to be either the same or better off than before our work started. So we had to relocate communities. In KZN, for example, we built a dam, but it was in the catchment. There was a lot of indigenous plant life and especially grass and wetlands, which was in the catchment area. So we had to rehabilitate all of that. There in Mpumalanga, close to Steelpoort, there's some indigenous plants there that only grow in the valley where that dam's catchment area is. So there was actually search and rescue to be able to, there was this one orchid that only grew there amongst the rocks. So there's a big search and rescue effort to go and get these plants out and relocate them and all of that. So for the least amount of social cost, right? So in fact, we want to move towards social profit. So those are some of the considerations. We'll start talking in our one example will be specific this product service cost, and I'll show you some strategies that different companies apply. Okay, so an interdisciplinary approach embraces both the product and the associated capabilities for production and construction, product and production system maintenance, and phase out and disposal. So that's also one of the considerations in our life cycle. And we talk about that. We said from need to disposal, right? So what is Apple doing these days? When you buy an iPhone, you can actually go and exchange your own old iPhone and get a discount on your new iPhone, right? So they're collecting all the old iPhones in order to look after that component of the life cycle, because they feel that there's some revenue to be recovered from these old cell phones, whether that's through recycling, meaning that they extract all the precious metals or whatever from those cell phones, or whatever strategy they're following. I don't know exactly what their strategy is. I'm not an insider to Apple, but they have a good example of how a company incorporates phase out and disposal into their system, right? But then there's also system maintenance and production. So we'll talk about that in a little while as well.
Sir?
Yes. You've got a hand raised. Let me just see who it is. Mr. Cholane.
Yes. Yes, sir. Thank you, sir.
Yeah.
What is the difference between the phase out and the disposal? Because
Okay.
in my mind, I think maybe they fall within the same category. But if you can explain that maybe further, I'll have a better understanding of it.
Okay, so it depends on your product. When you were asking your question, one thing came to mind. The South African military uses a carrier aircraft called the C-130. Now, if you stay in the Tshwane area or the Pretoria area, close to Waterkloof Air Force Base, you might have seen these airplanes. But did you know that those airplanes are decades old, right?
No, I know them. I'm working in the defense.
Okay, excellent. So you know the C-130s. To give you an
Yes.
example regarding that, difference between disposal and phase out. When those aircraft, those aircraft have certain onboard systems, including radar systems and flight control systems, right? When those aircraft reached end of life, the South African Defence Force, the SANDF didn't go and dispose of all of those aircraft. So in other words, took them all out of the sky and stripped them and recycled all of the parts, or just left them somewhere to rot, right? What they did was, at end of life of those aircraft, they brought them in, they did an end of life review, they analyzed the system, and they used companies. I think one of those companies was actually Aerosut, to help develop modernized onboard systems, including radar systems and flight control systems, communication systems, all of those systems. So what they did was they said that those aircraft, the C-130s, had a very good airframe. Obviously, the engines and all of that was a little bit inefficient, but what's the purpose of those aircraft? It's not commercial aircraft, so efficiency of the engines might not be a primary concern, but a primary concern in military aircraft would be those control systems and radar systems. So what they did was they went, this was 10, 15 years back when I was still involved there. They went and they refurbished all of the electronic systems on those aircraft, including control systems. And in that way, the C-130 was phased out, but they were able to let's say, reinstate those aircraft. So you'll also remember the Cheetah. They were phased out a few years back with the incorporation of what's that new aircraft that we have, the Gripen aircraft. So with the arms deal going where it went, Gripen aircraft started coming to South Africa, and the Cheetah that was also locally developed started phase out. But those cheetahs are still there. They're still standing there. They haven't necessarily been disposed. So in the case of disposal, we're talking about recycling, environmental impact, and impact, and that way. So there isn't, let's say, a technical distinction between those two, but I hope I could shed some light regarding phase out and disposal. Are you happy, Mr.
Yes.
Excellent, thanks. All right, so phase out and disposal. It depends on the context which word you will use. All right, so for instance, iPhone you will phase out, and for instance, Apple will stop, and Windows, for instance, might stop sending out updates. So that would be phase out, whereas disposal would actually be recycling and recovering items from it. All right, so let's move on. The cost effectiveness of the resulting technical entities can be enhanced by placing emphasis on the following. So if we want to improve the cost effectiveness of our technical entities, we can improve methods for defining product and system requirements as they relate to true customer needs. Right, so if we want to improve cost effectiveness, what do we want to do? We want to get as close as possible to the customer's needs, right? So why, if I'm producing a car, and this is just a very bad example, but if I produce a car, why would I want to include a reverse camera if that's not my customer needs, right? If my customer needs isn't a rear view reverse camera, it's just going to cost me more to include that into my design. And in the end, the customer is either going to pay for it, which is going to make us lose traction in the market because it's going to cost more, or we're going to pay for it, which reduces our profit margin. So what we want is we want to get as close to the customer needs as possible. And how do we do that? By proper product definition, right? So before we start, we want to define the product very accurately. Okay. So this should be done early in the design phase, obviously, right? So there's a graph that shows the longer your design or the longer your life cycle carries on, the more expensive it becomes to make a change, right? So for instance, let's take that car. I know the Ford Rangers, right? A few years back, can't remember exactly which model. But they did a recall on their gearboxes. The smaller ones did a recall on their gearboxes, right? So if you were the company that produces that car, would it have been more cost effective for you to sort out that design issue at the very start in concept phase? Or maybe a little bit more expensive, but least expensive in, say, prototype phase, and then in production phase, where you're actually starting to set up supply chains and starting to build your facility in which you will produce this car, or maybe even when the car is already out there. Remember, then you have to recall that car. Those parts have already been produced. You have to supply a replacement part. So now you've produced 2 of those parts for every car. Plus, you have to pay the supply chain costs. So the dealer that is recalling this car and fitting that new part, he also has to be paid with his labor. And that recall is all done at company cost, right? The customer doesn't pay for it. So it costs you a load of money to recall a car for a certain malfunction. But if you could have sorted that out, maybe even in conceptual phase, how much money would you have wasted? Maybe 1 day or 2 days of brainstorming regarding the product, which is a lot less than recalling an entire fleet of cars and doing that product twice, right? So obviously you want to do this as early as possible in the design phase. Along with the determination of performance, effectiveness, and essential system characteristics, right? So this system characteristics we already spoke about. That's not just about the car. That's the entire environment that our company provides for that car. And I'll show you just now what I mean. That's why I think this is a good example that I want to show you. Guys, feel free to interrupt me. Yes, Mr. Mashlangu.
Yes, good afternoon. I just wanted to ask what normally is the cause, because I remember even the Ford Cougars, you know, at some point they were burning out and stuff like that. I
Yes.
know probably in the process they do test out the things that we are talking about now, but which phase do you think maybe leads up to that? Like, do you think maybe they do the prototype phase and then everything goes well, and then once production starts, because when they recall them, they've already manufactured, you know, a lot of cars. So
Yes.
I don't know. Maybe you can just enlighten us what normally becomes the problem with
Right.
those cars.
My answer to you is not a simple answer. The fact is that in some cases it's one thing, in other cases it's something else. So what often happens, and this I can tell you, what often happens is there's a quality shortfall because of supply chain cost. So you remember, you as, for instance, let's take the Cougar or the Ranger that we just spoke about, right? You as Ford
Right.
won't manufacture that entire car from wheels right through to the sunroof, right? You'll have suppliers
Okay.
supplying different components supporting that. So in some cases, when there's a small disconnect, not even a large disconnect, a small disconnect between supply chain and design, right? Design would send through a specification to a supplier, which supply chain then would then purchase and incorporate into the production, right? But sometimes there's a small disconnect in terms of that specification and they or in quality management of supplied products. Right. So this is in my opinion most often the case. So the parts that you are buying in doesn't necessarily meet the specification that you set, the parts, and then when they get into application, because obviously the suppliers they compete on a tender basis or whatever, and you take the cheapest tender. And sometimes those parts don't necessarily meet specification or the design, and then you only realize that shortfall once those cars are starting to operate. All right. So that might be a case. There might be other cases. The Cougar, I believe, was designed for a certain environment. I believe it was designed for a more European environment that doesn't have these extreme temperatures that we have in South Africa. Okay, not that we have extreme temperatures, but they operate generally much hotter here in South Africa. And I think that was a small misjudgment on their part. As yes, they can operate under high temperatures, but can they sustain that operation in high temperatures? So that caused them to recall. But a recall in all cases is the last thing that a production company wants to do. So to give you some ugly insight into how companies decide if they want to recall a car. To give you an example of airbags. So say you produce a car and your airbags malfunction. What the company does was they go and do a financial balance to say, okay, if these airbags malfunction, how much do we have to pay out in claims because of people dying versus how much is a recall going to cost? And then they make a decision on which one to do. Do they want to recall or do they want to leave them as they are and then simply pay the claims that people do in lawsuits because of a malfunction? And I've got another example for that, and I'll show you a little bit later on what happened there. I've got an example with a Boeing, an aircraft. So that's a very good question, and sadly I don't have a specific answer. But a recall, what I can tell you, a recall is something that went terribly wrong somewhere. Okay, so recall is not something that's designed for, it's the last thing that people want. So it must be a mismatch in supply chain, a mismatch in terms of environment where the product is operating, or simply a design error. And I'll show you where there's a big design error on a Boeing aircraft that cost a lot for the company. I hope that answers your question. I feel like I didn't answer it specifically, but hopefully I gave you some insight.
Yeah, no, thank you. That was insightful. Thank you.
Great, thanks, Mr. Mashlangu. All right. Okay, guys, I'm gonna run towards the end where we outline the life cycle, and we can come back on Thursday. Addressing the total system with all of its elements from a life cycle perspective, very important, and for the product or prime equipment and its element support. This means defining the system in functional terms before identifying hardware, software, people, facilities, information, or combinations thereof. There's a very important part there. This means that the system must be defined in functional terms even before we identify what hardware we're going to use, before we identify what software, what facilities, what information we require. And it sounds as though we know that, and it sounds as though it's common sense, but it's not. How many times do you find that companies design a product from the facilities that they have's point of view instead of from what the customer requires point of view, right? So that might cause major issues. So you get company alliances that decide on software, for instance, even before they start. So your company might have a contract with Microsoft, and you rather honor that contract before you start identifying the system's functional terms, and that might even cause some issues, right? So that will cause your company not to become lean, because that software provider might not be the best software provider. And you've also got a facility, right? And that facility's got a whole lot of people, and this is where the social impact comes in. So I've got a facility, I'm employ a whole lot of people, and they've got a specific hierarchy. Now I'm producing a new car, right? So every how many years there's a new model that comes out. Now I set up my facility and my employees as the functional terms for how I design a product. All right, so that becomes a difficult road to tread, right? But the idea is for systems engineering is to start with a need, to define your product in functional terms before you start identifying hardware, software, all of that stuff. And I know in many cases it's very difficult, and it makes a very difficult thing. And I'll show you how it can backfire. All right. And that's one of the two examples that I want to show you. All right, considering the overall system hierarchy and the interactions between the various levels in the hierarchy, this includes intra-relationships among system elements and intra-relationships between higher and lower levels. So we spoke about those intra-relationships in chapter 1. All right, organizing and integrating the necessary engineering and related disciplines into the main systems, engineering effort in a timely and concurrent manner. This is a very important word, concurrent. So if you're a design engineer and you work for a company, where do you function? Is it only in the design phase, or do you have to be incorporated right through the entire life cycle? For instance, this Cougar now that burned down, or this Ranger that was recalled for the gearbox. Now, you're the design engineer there. Do you think you were only involved at the point where the product was designed, or are you actually involved right through the life cycle, right up to service and disposal when that recall comes in? So all of these efforts, all of these integrated components remain involved in a concurrent manner together with each other, right? And then establishing a disciplined approach with appropriate review, evaluation, and feedback provisions to ensure orderly and efficient progress from the initial identification of the need through a phase out and disposal. Here's also a very important thing. So there must be a feedback loop. So it helps you absolutely nothing. If you are in the conceptual phase, you're a systems engineer, and you identify needs. But during the design process, there are a few things changed. During the production process, there are a few things changed. And through the marketing process, the marketing guys decide to market something else. And I'll show you one of those examples now. There has to be a feedback review to always go back to the customer need, because in the end, you might not be selling a product to the customer that they want, or that you actually defined at the start, and in that way you lose market representation, right? So there must always be a disciplined approach for review, evaluation, and feedback, right? So this ensures that you always remain on target, and this also helps in designing a lean company. Okay, I want to get to one slide, so we'll carry on here on Thursday 9. I just want to carry on with this slide, right? So when we talk about life cycle, what does that mean? A life cycle is the identification of needs. We must know what the client wants. And then we do conceptual design and preliminary design. This might include prototyping. Then we do detailed design and development. And this is where our supply chain and all of that starts to come in. And then obviously production and construction. So there we have to look at our plants and our facilities that produce this. For instance, if we're a multinational corporation, we might have production facilities in a lot of different countries. So which one of those production facilities do we want to produce this car? A good example is Nissan in South Africa, up here in Roslyn. They won the new Navara, So Nissan, the global Nissan company, decided to produce the Navara here at this plant. And this plant had to show that it can produce that. It had to show that it meets quality targets and all of that to be able to produce that product, right? So that's where production and construction comes in. And here's the part that most people forget. Product utilization, phase out, and disposal. What does product utilization mean? And that's where I want to get at. Now, I think I'll do the Boeing last, just to shock you guys. Okay, so let's go to these examples. Right. A few years back, when my baby was born, my boy now, he's not a baby anymore, he's now a full-grown boy. Nonetheless, we were in the market to buy a family-orientated SUV. And two different cars stood out for me. The one was the Tiguan. Let me just scroll up to show you the Tiguan. You know the Tiguan. The one was the Tiguan, it's this car, and the other one was the Nissan X-Trail, right? So the other one was this one, which you also know. You see these guys on the road often. Now, from a company's point of view, what do you know about these two cars? Okay, so the VW might be a little bit more expensive than the Nissan, right? The Nissan is a little bigger in terms of space inside and all of that stuff. So there's obviously competitive advantages. Now, when you design this car, Nissan went and they designed this X-Trail. And maybe let's start with the Tiguan. So VW went and they designed this Tiguan, right? So they've got client specifications and all of that. And they considered designing the car. So they sourced all of these parts and the engines and the wheels, and they're producing it, and they're moving it all around the world to sell it. But that's not where they end, right? You know, when you buy a new car, you can go and service it, and it comes out with 2 additional items that isn't on the car. It's an agreement with VW, right? With the supplier, with the original producing company. Those 2 agreements are, the first thing is a warranty, where the company says, if something breaks, I will fix it for you. No cost. I will fix it for you. The second thing is a service plan, right? Where they say, okay, every 15,000 kilometers, we want to replace the oil and check the bearings and replace the spark plugs and whatever. Okay, so every 15,000 kilometers, we want to do that. Now, the supplying company, which is VW, the producer, obviously that costs them money, right? Because they're paying for it. If something in this car breaks on a warranty, I take my VW to the shop. I tell them, listen, this thing broke, and they replace it for me for free. For me, the customer, I don't pay anything for it, but someone has to pay, right? Because there's someone stripping down this thing, and there's a part that needs to come in. Someone's paying for it, but it's not me, the customer. Okay, yes, eventually it is me, the customer, but when I buy or when that thing breaks, I didn't go to that service center and pay for the new part. It's under warranty. And the same thing as well is when I take it in for a service, every 15,000 kilometers, I don't pay for that service. VW pays for that service, right? So when we go back to our life cycle, That's a big expense in terms of you that produce the car. Né? It's a big expense for you. So that obviously has to be included into our original design. And it has to be designed according to the need, right? The client need. And I'll show you the two companies' different approaches now, all right? So product utilization is also something that costs us money. It's not only when we start producing the car and we buy the parts and all of that costs us money. This product utilization might cost us a lot. And to give you an example, now my X-Trail, the one I bought eventually, and the Tiguan, the one that I still like today. Okay? So here's all the specifications, so engine capacity and transmission and all of that stuff, all of that plays a role. But something that you can see from the brochure, how many items are listed there. And look how small this last item is that I spoke about now during utilization. So here they say this is for the Tiguan, eh? Guarantees. They've got a 3-year warranty, 120,000 kilometers. So if something breaks within the first 3 years that you bought that product, they will replace it for you. And then a 5-year or 90,000 kilometers service plan, right? So for the first 5 years, for the first 90,000 kilometers, they will service that car for you. And if you know what it costs to service cars, it's anything between 3,000 Rand and 15,000 Rand per service, no? Every 15,000 kilometers. So there's, what, 6 services there. 6 times, let's say, okay, it's a Tiguan, so it's a little bit more expensive. Let's say 6 times 7,000 Rand. 6 times 7,000 Rand. It's 42,000 Rand on a car that costs you 400,000 Rand. So it's more than 10% of the car's cost that you are giving the client for free with the car, right? And the same goes with the warranty. So that's what VW did. Now I wanna compare these two for you. So there's this one's guarantees, 3 years, 120,000 kilometers. Let's look at the X-Trail. All right, okay, guys, please note I'm not promoting any brands. This is just a comparison. I can tell you which one I bought, but I can't tell you which one is the better one. Let me just zoom in here. All right, so here, service and warranty. So service plan and warranty on the X-Trail, and here is where the catch comes there. So the top one is service plan. So VW's got a 3-year, 120,000 kilometer warranty, whereas the X-Trail has a 6-year, 150,000 kilometer warranty. So you can see the difference there, in terms of cost or investment from the producer. Service plan 3-year, 90,000 kilometers. On the Tiguan, the service plan is 5 years. So you can see the weight that these two companies place on those 2 additional items during the utilization phase of this car, right? So you can see that Nissan puts more value in the warranty than they do in the service plan, whereas VW puts more value into the service plan than the warranty. So you can drive an X-Trail for 6 years, 150,000 kilometers, and not worry about anything breaking, whereas on the VW, it's only 3 years, right? But with a VW, you can service that car for 5 years, whereas with the Nissan, you can only do it for 3 years. So there you can see how these two different companies balance that component. But the important part is a VW, let's say the Tiguan costs you 7,000 Rand to service, which I think is a very low estimate. I think it costs more, right? 7,000 Rand to service. Every 15,000 kilometers, 15 goes into 96 times by 6, 42,000 Rand. So it's 10% of the car's value that this company invests into the utilization phase of this car. So that's why design for life cycle is very important, right? I want to just give you a second example. Here is the Polo, the new Polo. Here's the new Micra, right? So here's the guarantees, service plan there. So the Micra also has a 3-year 90,000 kilometer service plan, whereas the Polo has a 3-year 45,000 kilometer service plan. Here you can start to see a difference, né? So for the Micra, Nissan gave a bigger service plan for the Micra than VW did on the Polo. This is only a 45,000 kilometer service plan. And you can see at this one manufacturer the difference between the Tiguan and the Polo as well. The Tiguan's got a 90,000 kilometer 5-year service plan, where the Polo only has a 3-year 45,000 kilometer service plan. And with the Micra, it's a longer service plan. And then again, the warranty, here you can see the difference in warranty as well. Warranty 3-year 120,000 kilometers on the Polo, whereas the Micra's got a 6-year 150,000 kilometer warranty. So you can see that in the Micra's case, Nissan invested a lot more in the utilization phase than VW did with the Polo. You can see here that with the Polo, they didn't invest so much during the utilization phase of that car. Can you see that? So there you can see a clear difference, and between these two as well. This is a higher end car. It's a more expensive car. And the client that buys this car would generally keep it for more than 5 years, right? Whereas someone that drives a Polo would usually want a new Polo every 3 years when it comes out. So that's why they only invested for 3 years, whereas with this one, they invested for 5 years. So that comes from client need. Né? So you can see how VW alters these types of utilization phase of the life cycle to match their client needs. Whereas with Nissan, the Micra and the X-Trail are exactly the same. So they expect the same guys to be driving an X-Trail and drive a Micra. So that's quite cool, né? Before we carry on, maybe you've got a question or two, Mr. Gresse?
Yes, thank you, sir. I wanted to ask with regards to life cycle and planning and designing of products, or more products, not necessarily services. How big of a factor is the client or your target market to how you would design or approach your designs with regards to the whole life cycle, even to the end of the product utilization? Does it have a big effect on it, or not necessarily for the target market?
The target market's got the biggest influence. So yes, you have to consider supply chain. Yes, you have to consider production and availability of materials. Yes, but your client is the center point around which you design. You always come back to client need, right? So there is a little bit of variation in that, Mr. Gresse. I'm not saying, listen, whatever the client says you must implement. I'm not saying that. But what I am saying is, for your company to be able to improve its market share, what must happen? People must actually buy that thing. Né? So your involvement in the market in terms of both price level and in terms of functionality, it must match up very well to a specific market segment. Right now, there are places where you might misalign to some extent, but still gain market share. For instance, in South Africa, South Africa versus Europe, the normal 20-something guy that buys a Golf in Europe, in South Africa can't afford a Golf, right? So they buy the Polos. So Polos are one of the best-selling cars in South Africa. But in Europe, it's not. The Polo is not one of the best-selling cars in Europe. The Golf is. So they might have designed the Golf for the 20-something working guy, and in South Africa it's not applicable. But there's still market share there. But to answer your question simply is your target market must be central to your design endeavors. Mr. Sekatane and then Mr. Gresse again.
So I just want to ask, what is how do companies get their data in terms of what is it that the clients are looking for in their product? Is there some sort of systems that they use to gather that data?
Yes, very, very good question. Very good question. Okay, so obviously they monitor sales, and they monitor other companies' sales. So that's point number one. If they start to lose sales or they start to gain sales or whatever, they start having a look at what happened there. So obviously market information comes first. And then secondly, there's a little bit of black magic. Okay? I've got a friend, his wife is a fashion designer. Or not a fashion designer, she's a buyer. She's a buyer at a clothing company or a clothing seller in South Africa. I'm not going to say which one, but she's a buyer. But she buys 1 to 2 to 3 years in advance. So in her case, she can't go and say, yes, but jeans sell so much and T-shirts sell so much. She has to do a certain amount of, let's say, regression on market trends to be able to predict where sales are going, right? So that's why I say it's a little bit of black magic, right? She has to take market trends and she has to look at fashion shows and she has to look at the rappers and all the musicians and pop culture and all of that in the market segment that she's focusing on. The market segment that she's focusing on, for instance, is teens, right? She's a buyer for teen clothing. So what's popular in teen clothing or what's popular in teen culture? And she uses those trends to try and map what will be in style in a year's time, in 2 years' time, to start setting up supply chain agreements to be able to purchase those clothes. And when they do come into the shop, they are fashionable. Instead of saying, yes, but it's last year's news. All right, so that's very difficult. In terms of cars, in terms of that type of stuff, yes, market share and market analysis will play a big role. So you can see, okay, but sales in South Africa is focusing towards SUVs away from sedans. Then you can say, okay, but based on this, what SUVs are selling well, these SUVs and those SUVs, or what are the client needs in that regard? So more cars with sat-nav sold than cars without sat-nav. Clients were willing to pay more for sat-nav. So let's incorporate sat-nav. And then also incorporation of technology that the market isn't aware of yet. So in that case, a cell phone company might be a good example, right? Have you ever wondered why, or this is a conspiracy theory, but have you ever wondered why there's so many iPhone leaks before the iPhone is launched? Maybe, and this is a conspiracy theory, but maybe Apple has connections in the leak market that launches a few leaks just to test people's response. To say, okay, yes, but let's keep the notch or let's do a cutout for the camera on the front screen. And then one leak says, yeah, but the new iPhone will have a notch. And the other leak says, no, but the new iPhone will have a cutout. And then maybe Apple is sitting back and watching what the responses are to say, oh, okay, but the client wants this or the client wants that. So I truly believe that if not planned, I really do believe that Apple has a very big social presence in which they monitor these leaks and see what the response is from the environment. So it depends from company to company, obviously, but there's a lot involved. In automotive manufacturing, I believe it's mostly sales trends and then also development of new technologies. I hope that answers your question. It's a big story now, but I hope that answers your question depending on what product you're producing.
Yes, it does. Thanks.
Thanks. Mr. Gresse, let's do your follow-up question.
Thanks, sir. So that basically then means your target market is the reason you would a car company would bring out. So, for example, if we look at the Hyundai i20 compared to the Polo, the Polo had a new edition or a new version coming out more often than the Hyundais or the Opel, the Corsas. You see.
Yes.
So does that mean then that your target market is your reason, or your targeted audience is your reason for constantly, in a sense, updating your car to bring out a so-called new one?
Yeah. Look, it's a balance between what your client needs and what your company targets are, right? I believe there's a reason why cheaper cars have a quicker cycle than more expensive cars, right? So guys like the high-end cars, the Bentleys, or even not as high-end, let's say the Mercedes, the BMWs, they've got a longer refresh cycle, right? Because I think the production of those cars or the development of those cars cost a lot. But also because they've got a more stable market. Those guys that buy those cars usually drive them for 5 to 7 years before they want a new one, right? Whereas the guys that's buying the Hyundai or the Polo or whatever the case may be, I think they require a more rapid upgrade, and I think the development in terms of those cars also cost less. So it is a balance between your company's targets, but also what your market requires. Obviously, you can't sell something to the market that the market doesn't have money for. So if you bring out a new car, even though you can afford it, a new car every year, your client's not going to buy a new car every year. So you're gonna lose traction in terms of your market. But in terms of the Polo, if you do a refresh every 3 years with a new model coming every 6 years, that I think was a very sharp balance. And you can see where the balance comes in terms of how the different manufacturers have reached consensus on those timelines, right? So guys like Nissan, VW, Hyundai, all of those guys, they've got a certain refresh rate. So every 3 years they do a facelift. Every 5 years or 6 years they've got a new model. Whereas the more high-end guys, they have the same trends, like BMW and Mercedes. They've got every 5 years a refresh, maybe every 8 to 10 years a new model. And it also differs from model to model. For instance, your S-Class Mercedes versus your C-Class Mercedes. So yes, I think it's a communication between market response and then targets of your company. But that's where systems engineering comes in. We're talking about interdisciplinary approach now. So that's where your company values and all of that, your targets come in. But obviously you as a systems engineer have to take into account what the market can achieve. Mr. Matebula, I think yours is the last question. I want to show you one shocking example of what went wrong with one of these designs. But let's just answer your question. Mr. Matebula.
Oh, thank you, sir. I think it was based on the example that you made of the person that was making orders for the for the trending fashion and everything. So my question was based on the product life cycle, judging by I think there's a waterfall design, and also now there's an agile, and most companies that are focused on the agile. So I wanted to know, when it comes to the agile design, how do you now maybe come up with solutions for the utilization step when you're doing the product life cycle?
Mm-hmm. Very good question. I'm going to give you 2 examples. The first one is obviously fashion industry. If you're a clothing producer or manufacturer in China, what do you have? You've got a lot of flexibility in terms of production. When you produce a car, you can't use the same stamp for the Polo and for the Tiguan, right? So you have to have a specific facility for that specific car. Whereas with clothing, it's different. So they're more agile, right? So they're very quick to respond to what the client needs. The second one, and that's where the catch comes in, is cell phones and electronics. They've got a very short refresh rate, right? So those companies like Samsung, companies like Apple, companies like Huawei, companies like Xiaomi, they have to be extremely, extremely agile. But now they have to have a specialized facility in order to produce, right? In order to achieve agile, firstly, you have to be closely connected to your market, because you have to know what's trending now, not in a week's time, not in 2 weeks' time, now, right? Second thing is, in terms of your production and design capacity, you have to be able to transform your manufacturing facility or your supply chain on a very short notice. So, for instance, electronics, you've got major CPU producers across the world, and they are developing new CPUs as they come along. But Apple is capable of changing their supply chain in 6 months' time. So they can buy one CPU from one guy. The next 6 months, they can buy a different CPU. Now they're producing their own CPUs. So they're very agile in that regard in terms of supply chain and production. So it depends on the area that you're focusing on. But for agile, and the whole world is moving towards agile, why? Customization and a more rapid development of products, right? So even cars are taking shots because of this. So what are cars doing? They're having facelifts, right? So the basics, the large components of your cars aren't updated, but the visual effects of your cars are updated. So the cars, you can produce the same car for a longer period of time, which reduces the amount of variations that you have in your production facility. But your client still gets an update on short periods of time, right? So agile is becoming more relevant. And if you want to have a company, your company has to become even more agile than today's companies are, because in the future it's going to be even more so with Industry 4.0 and this same-day delivery structures and all of that stuff. All right, guys, I hope I answered your question. I want to show you one example of where it went wrong, right? We spoke about design for lifecycle. Lifecycle includes all of this. I want to show you guys an example of where it went wrong. Okay, so. Sorry, let me just take a sip of water. My throat is struggling. So in the space of comparing fashion to electronics to cars, what do you see there is the cost for developing a new product, the development cost for producing a new product, and which ones are at the very highest end of that scale. And yes, there's a picture of one of those on your screen now, but can you imagine what it costs to develop a new airliner, a new commercial airliner, right? It's ridiculously expensive. Where you think developing a new car is expensive, where you think developing a new phone is expensive, a new airliner is crazy, crazy expensive, right? Now, in the last decade or 2 decades, international commercial flight sector, aerospace sector, has changed dramatically. And now you have guys like Airbus and Boeing and Lockheed Martin and all of those guys that produce commercial aircraft, and more agile environment, client needs, 9/11, where they had to upgrade the security features and all of that stuff, including more efficient propulsion and environmental concerns, right? So how do these guys stay relevant in a market that changes every 5 years, but it takes them 20 years to develop a new product? So let me tell you the story of the Boeing 737-8 MAX or 800 MAX, right? So in the early 2000s, Lockheed Martin and Boeing, they merged, right? And there was a big movement towards more efficient aircraft. Why? Because it's becoming expensive, right? Fuel is becoming very expensive. And then also environmental impact. So what Airbus did was they took the A320, and it was a newer aircraft than the 737. And they developed a super efficient aircraft. And with that, they had an update on that aircraft called the Airbus A320 Neo, which had more efficient engines and which was a lot lighter. And Boeing had trouble. They were losing market share at a ridiculous rate. They used to be by far the biggest commercial aircraft manufacturer in the world. And in the 10 years after the 1990s, they started losing traction in the market at a very fast rate. So they made a decision. They had a new airliner in development called the 787 Dreamliner. the 777 Dreamliner, 787. I can't remember the number. You can correct me if I'm wrong. But nonetheless, with that new aircraft, they had a problem, because with these new aircraft, obviously there's a whole infrastructure change, right? That infrastructure change includes training simulators and all of that stuff for pilots, which cost airlines a lot of money. So airlines would not necessarily buy a new aircraft, right? They want to operate their old aircraft, but they just want them to be more efficient, okay? So what Boeing did was, and it was a strategic decision, they took the old 737, which was one of the best-selling aircraft ever to be produced. They took the old 737 and they produced a more efficient version. So they gave it a more efficient engine. That was the big upgrade, was a more efficient engine. But these engines were larger and heavier than the old engines. But it enabled this 737 to fly much more efficiently. Okay. Part of their sales pitch to airlines was, guys, you don't have to retrain your pilots. You don't have to upgrade any of your infrastructure. Everything stays exactly the same. It's exactly the same aircraft. It's just double more efficient. And it's even as efficient as the A320neo, right? Worked well. These 737 MAX aircraft took off. People were buying them, right? So they did very well in sales. But it was a strategic decision from Boeing. And it was one of the big airline or aircraft conspiracies and scandals of the last 10 years. What happened was, in the design phase, because of these larger engines, they designed a special tail configuration, electronic tail configuration, that adjusted the pitch of this aircraft. I'm not an aeronautical engineer, so please just bear with me my wording. But it automatically controlled this rear wing to adjust for the additional weight here. But the pilots weren't aware of that. This was called the, so you can see there the bigger engines. So this was called the MCAS system, right? The MCAS system, to control this tail plane so that they can counter for the additional weight. They didn't tell the pilots about this. They didn't even tell the airlines that bought this aircraft about this new system. So the pilots weren't aware of this. Even the airliners weren't aware of this. And what happened was, this system malfunctioned. And the airline or the pilots had absolutely no training to be able to compensate for the failure of this new system. They weren't even aware that there was a new system online. So this pilot stepped out of his old 737 into the new 737 MAX. They took off, and all of a sudden, this aircraft pitched down. It was nose down, and they didn't know why. And they were fighting this aircraft, but as much as they fought this aircraft automatic system fought back. And what it caused was that in the time of about 6 months, 2 aircraft crashed and 346 people died. And subsequently, they grounded this new aircraft, which was one of the best-selling aircraft in the world at that stage. They grounded that aircraft for more than a year, for a year and a half. And airlines took financial shots. Obviously, Boeing took financial shots, but obviously the biggest problem was 346 people died because Boeing, as part of their life cycle design, product utilization phase, said that the pilots didn't need new training in order to gain market share for this new aircraft. And when talking to the design engineers of this aircraft, they had minutes which came up in reviews after why these aircraft crashed. There were minutes that the design engineers actually said, listen guys, You have to train the pilots of these new aircraft to be able to handle this new automatic system. And Boeing made us a strategic decision to say no. No, we're going to lose market share because that's additional cost to the buyer. They're not going to do that. They're going to keep this under wraps and hope nothing fails. In the end, Boeing was charged with fraud, and they had to pay $2.5 billion in penalties and compensation to the families because of this design error. So there you can see how a company went, and to be able to gain market share during product utilization, they made a strategic decision, and it didn't link up with their design decisions. And because of that, they suffered major catastrophe. You know that commercial airliners is the safest way to travel on Earth. In about 6 months, 346 people died because of a bad decision that the corporate side of Boeing made in order to gain market share and reduce cost of product utilization for the client. So there's just a horror story of how it can go wrong. Okay, guys, maybe 1 or 2 questions regarding that, and then we're going to close this session. Oh, thanks, Mr. Gres. I didn't even know there was a documentary. So now you can really go and check my facts. Go and watch the documentary and come back and tell me how I was wrong. Guys, but that's, I believe, is a beautiful example of how being too, let's say, market related and not using systems engineering to incorporate and interlink these different components of your company can have a big backlash and can cause a lot of trouble. I mean, in this case, it wasn't even just company cost, it was human life, right, guys? So 346 people died because of this, let's say, corporate decision that Boeing made. Okay, guys, you happy? No questions? Thanks, guys. Look, I always try to keep it applicable when you go out there and you go into industry. And for that, I'll urge you guys to talk to me, right? So one of you guys told me you're working for the SANDF. I'm sure other guys have had exposure elsewhere in other companies. So obviously your information is also valuable to contribute to our class. But thank you very much, guys. I think we had a very good interactive session today. I think it went really well. So thank you for your inputs and your questions. I think we really gained value. But with that being said, I will then see you Thursday morning, and then hopefully we can make some more traction with chapter 2. So I'll just go through those 2 slides that I skipped now to get to this, that I want to show you the 2 examples. I'll just go through those 2 slides and then we'll make some progress with this. I'm going to try and finish these slides, and then next week we'll go through the diagrams, because I think the diagrams like this one is very valuable. So you can see the parallel processes as well as the chronological processes, which I think is very valuable and gives you a little bit more insight into this. All right. So thanks, guys. With that, I'll see you Thursday. Have a great time. Study hard, and good luck. Cheers, guys.
Thank you, sir. Have a great day as well.